Hello, my name is Madeline Zalman, and today we will be talking about nuclear physics. Now, when some think about nuclear physics, they think of giant explosions like in Hollywood movies, but really, that is not the case. Sorry for the poor drawing. It all starts inside of an atom. In the center of an atom, there is a nucleus, which is made up of nucleons, including protons and neutrons. For the basic setup of nuclear equations, they have the mass of the atom on top and the number of protons on the bottom, here presented. Now, what really happens inside the nucleus is that when the energy is presented into the system, it pushes the neutrons and the electrons away. Now, this energy is presented can be used with this formula, where Z protons times the mass of the proton and N neutrons times mass of the neutron minus the mass of the atom. Now we will talk about the different kinds of decay. The first decay is alpha decay. Now the daughter atom is 4 less of the mass and 2 less of the proton of the parent atom. This is added with the alpha decay of H4. Next decay has 2 parts. The first part is beta plus. Here the daughter atom has 1 less proton than the parent. This is when a proton changes into a neutron. Adding on to that, then we have beta minus. This happens when an electron leaves the atom. Here, the daughter atom has plus 1 proton than the parent. And finally, we have gamma decay. Gamma decay parent atom does not change, but the atom itself makes a quantum jump. Now, represented in this next picture, you can see it originally goes through a beta minus decay with energy leaving the system, and then jumps to a lower state by the gamma decay itself. Now, lastly, we should discuss half-life. Here is the half-life equation, where if you know the initial amount of time and what exactly the half-life of the atom is, you can determine how much of the atom is left. Here, the half-life of carbon is 5,730 years. If you want a specific time and you know what you started out with, you are able to find out how much of the atom is left. Well, that's it for nuclear physics. I'm Madeline Zalman, and I hope you enjoyed your lesson here about nuclear physics. Have a nice day.